Let's briefly talk about defining classes and creating class diagrams. A class definition is a set of program statements that describes the characteristics or attributes of a class's objects and the methods or actions that can be associated with the individual objects. The class definition usually contains three parts. Now, every class must have a name, but not every class has to contain data or methods. Usually they do. It's possible to define a class with attributes, and initially the class has no values in those attributes. But it's very common to have default values in the class definition, so the class itself does have data. Again, most classes contain methods, but it's not a requirement. You can define a class that has no methods. Just declaring the class does not actually create an object. Remember, a class is like a blueprint, and drawing the blueprint of a house doesn't actually create a house. You have to use that blueprint or plan to build your house. So in programming, you instantiate objects based on the class definition. Now, once the object has been instantiated, the object will have access to all of the attributes and the methods within the class definition. And we use what's known as dot notation to access those methods. The object identifier, such as a variable like my assistant, dot the method, in this case set hourly wage, and the 16.75 is the argument being passed to the method. And this is an example of what is probably an employee class. Keep in mind that this is basically an example of pseudocode for instantiating an employee object named my assistant. Depending on which programming language you use, the syntax will be very different. But by instantiating this my assistant instance of an employee class, the my assistant contains all the data fields of the employee class, and it has access to all the methods within the class. Here's some pseudocode of declaring an employee class object called my assistant, and then using the set method for last name, the set method for hourly wage, and then an output statement. Again, this is pseudocode. Depending on what language you're using, the syntax would look very different. Here's a class diagram. They typically have three sections. The top section contains the name of the class. The middle section contains the names and data types of the attributes or fields. And the bottom contains the methods. Again, this is the diagram. This is used in the planning stage. Typically, you wouldn't put default values in here, but you could. And some more pseudocode showing the employee class, the declaration. It has three attributes: a string attribute for last name, a num attribute for hourly wage, and a num attribute for weekly pay. And then there's several methods. This term void means that the method will not return a value. So set methods, set last name, set hourly wage, and then a string method to get last name, and that's when outside the class it's requesting the last name of the employee, and that last name value, the data, would actually be returned back to the program requesting this data. Again, get hourly wage would return data to the program, and get weekly pay would return data to the program. And lastly, we have another void method called calculate weekly pay. This method, again, it's void. It doesn't actually return data to the program, but it calculates the weekly pay based on hourly wage and work week hours. That weekly pay is put into the weekly pay attribute, and then from outside the program, the weekly pay can be requested using the get weekly pay method. So the purpose of the employee class methods, there's two methods that are used to accept values from the outside world. Those are your set methods. And then there are three methods that send data to the outside world. Those are your get methods. And then one work method that performs work within the class.